Welcome to Intermediate Programming with Python in Mini 3 of 2022. In this first week, we're going to start out with a review of Python topics that you should already know. On the left side here, I have the slides for the course, which I have stolen with permission from Professor Barrett. And on the right side, I'm using an idle integrated development environment, which I really recommend against you doing. But for me, it creates just a very clean interface for examples. Okay. So you can run the interpreter for Python multiple ways. You can run it at the command line by starting a Python shell and just typing Python or Python 3 or some similar command. That's a very primitive approach. Probably the best approach now is to use Spyder, which comes along with Anaconda, and you can launch that from within Anaconda Navigator, or if you have pinned it into your start menu, you can launch it from the start menu or from your taskbar. If you're using a Mac, then you can launch Spyder from Anaconda Navigator. As an alternative to Spyder, PyCharm is very popular with many people. You can also use Jupyter Notebook. Jupyter Notebook is very handy for interactive testing in in analysis. Some people are really into Jupyter Notebook. My own opinion, which you are completely free to ignore, is that Jupyter Notebook is great for data analysis, on-the-fly kinds of work, in much the same way that Excel can be used for on-the-fly kinds of work with tables of numbers. But for developing code that you then want other people to be able to execute, something like Spyder or PyCharm is probably preferred. Here is an illustration of the Spyder interface. If you have gone through my video describing how to install Anaconda, I did a little demonstration in there of how to make use of Spyder. For my lectures, I'm going to stick with idle, although I don't recommend it for you. Now, we're going to make a distinction here between a script and a program. A script can just be a file containing a sequence of ordinary Python statements that you can execute either by clicking a run button, or at the command line you can say Python and the name of the script, or Python 3 and the name of the script, or what have you. In a program, by contrast, we're going to require, and this is a conceptual distinction, it's not a technical distinction. The Python language itself does not distinguish between scripts and programs. But for us, a program is going to be a file containing just Python function definitions. Okay, so all of the program's code has to be inside of functions, and that program can either be executed itself or can be imported into some other script or program in order to be able to access the facilities of that program. For example, we have a module available by default in Python. A module available for us in Python called math. We can say import math as M. And now I can access various functions contained in the math module. So almost everything that's in math is function definitions, although there are also a few variable definitions as well, like pi. Okay. So to make things a little more clear, here is the distinction between, or here is an example, a short example of a distinction between a script and a program. In a script, we might have some function definitions. Here we have a function named myfunc that takes one argument that we're going to name x, and the function does something with that argument that it receives. And now we're directly calling that function in order to do something. This code, myfunc, is not inside of a function. That is, every time you run this script, myfunc with an argument value of 10 is going to be called. On the other hand, here we have a similar kind of thing, but it's been elevated to be a program. Not only does myfunc exist as a function definition here, but we have also wrapped the call of myfunc in another function called main. Okay, and by using this comparison of dunder name with the string dunder main, dunder meaning double underscores on either side, we've made it so that if this program is imported into some other module, the program doesn't do anything when it's loaded. In order for the contents of the program to actually do something, the code that has imported, all right, now this is not going to work, but if I say import myfunc as mf, I'm going to get an error message from that, of course. Then I will be able to say mf.main if I want to execute the main function, or I can say mf.myfunc with some argument if I want to execute the specific myfunc function. But the default behavior is that when you import this program, nothing happens unless you then make a specific request by calling a function. Or in the case of math, by accessing some kind of global variable that's available, like pi. Okay, so a variable stores information, and the information can be of the so-called basic or low-level scalar data types, or it can be a higher-level data structure. For the basic data types, remember that we have int, float, str, and bool available in Python. For the higher level data types, we have things like lists, tuples, sets, and dictionaries. Remember, by the way, that the name of a variable has to consist of, first, a letter or an underscore. That's required. And then optionally, there may be additional letters, digits, 0 to 9, and or underscores. So that's a legal variable name. In terms of arithmetic and Boolean and conversion kinds of operations, you definitely need to know assignment in order to be able to store a value into a variable. All right, so if you just say a, that doesn't create anything called a. You have to assign something to a. Here I'm assigning the value 123 to a, and that creates a variable called a, referring to that integer value 1234. Now, another way of creating an object is to define that object as a function. So I could say define A by in some way. Okay, and so now I also have this thing A, but now this thing A refers, it's a variable, but it refers to a function that I can call. All right? So that's how you, a couple of ways of creating a variable name. With the single equal sign, the gets operator, you can set up the variable to refer to a value. With the, the def and the variable name in parentheses, you can define that thing as a function. Recall that you can do what's called multiple assignment by putting multiple variables on the left side, separated by commas, and then your gets operator, your assignment operator, followed by an equivalent number of things on the right side. Okay, so now A refers to 1234, B refers to ASDF, C refers to false. The number of variables on the left and the number of values on the right must match, otherwise you get yelled at. All right, now for arithmetic, we have this slew of operators here. Addition, subtraction, multiplication, ordinary division, floor division, modulus, and exponent. We can also use parentheses for grouping to change the order in which various things are evaluated together. And we have these assignment operators that I like to pronounce as plus gets and minus gets and times gets and so on. I notice that star gets is not in this list, but it you can use it as well. For strings, for strs, there are some operators that we can use. We can use plus for concatenation. We can use star for repetition. We can also use square brackets as a subscript operator to gain access to a one-character substring or a multi-character slice of a string. Boolean results can be obtained by comparing two objects for equality or inequality, or for their relation, greater than or equal, less than or equal. And we can also combine together Boolean results with and, or, and not. And now, please recall from your introductory course that these have a very strict precedence hierarchy. You can modify the precedence by using parentheses in the same way for Booleans that you can for numerical values. We've also got various conversion and querying kinds of functions. The type function will tell us the data type of an object. Int will convert something to an integer if possible. Now that something might be a string, it might be a float, it might be a Boolean. Likewise, we can convert something to a float. We can convert almost anything. Well, I'm going to say anything. I can't think of a single thing that you can't convert to a str. You have to be able to convert things to strs in order to be able to display them to users. Now, isInstance is to do with class hierarchies, so it may be just a touch premature for us here to talk about it. Now, I don't talk about isInstance in my intro course. It's entirely possible that Professor Barrett does that. Let me just show one example with isInstance. I can query whether something, 1234, let's say, is an instance of a string, let's say, and that's false. Or I can query whether 1234 is an instance of an int, which it is. Now, if I query whether 1234 is an instance of a float, this is interesting because although 1234, pardon me, the value 1234.0 can certainly be represented as a float, the data type of this thing, 1234 without a decimal point, is not a float. Okay? Okay. We also, in the intro course, talked about various libraries or modules, such as math. You can, by the way, and I'm not sure that I did describe this in my intro course, but it turns out that any module, you can learn about the contents of that module by asking for its directory. All right, so for the math module, let's suppose that I wanted to know everything that is inside that module. Hello? Oh, I know why. When I said import math as M. So my Python shell here doesn't actually directly know about math. It knows about M. So I ask for a directory of M, and I get all of the names that are defined within M. And notice that that's presented to me as a list. Okay, so I've got arc cosine, arc hyperbolic cosine, log, pow, sine, ceil, etc., etc. Remember also that there are different forms of import. If I say import math, then that imports the entire module math, and in order to access items from within that module, I have to say math dot and some item like cos or math dot e for the value of the constant e, and so on. If you only want to import some, whoops, too much highlighting. If you want to import just a few items from a module, and you would like to be able to access those items directly without having to type the module prefix in front, you can say from the module import some collection of items. Now, this particular example on this slide just shows importing the sine function, but I can say from math import cosine, sine, tangent, let's say log and exp. And now I have those 5 math functions, and I don't have to say math.cosine, math.sine, math.tangent to make use of those. I can just say something like cosine of, well, I didn't import the pi constant, so I am going to have to say m dot pi. All right, I did import math as m up here, so I can say m dot pi to get the value of pi, and it turns out the cosine of pi is -1. Okay. On the other hand, the sine of m dot pi is 0. Ha ha. All right, so the sine of pi is 0. However, the sine function is not able to compute and return an exact 0 in this case. For one thing, because the value of m dot pi is only a very close approximation of the real value of pi. Pi has infinitely many digits, and m dot pi, is not infinitely many digits. So I get a value that's really, really, really close to 0, but not quite 0, and so on. Okay. Here are some examples that I'll just walk through. Here I'm saying x gets 4. That creates a variable called x and causes x to refer to the integer value 4. All right? So if in my interactive shell, if I just type x, I get the value of the object that x refers to. I can ask for the type of x, and I get told that x is an int. If I now say y gets x to the power of 2, okay, now I'm in the habit of typing spaces around my operators, and I'm consistent about that, but it's totally my choice. Other people are totally consistent about not having spaces around their operators, so you can do it either way. Now, x is an int, and 2 is also an int, so this is going to give me the int 4 to the int 2 power, which is going to be the int value 16. And I can use type to check that that's the case. All right? Okay, if I say z gets x to the 0.5 power, now, this is a convenient way of computing the square root, because in Python we do have the exponentiation operator, star, and if I take a value and take that value to a fractional power, the result is guaranteed to be a fractional or floating point result. Even though, in this case, the value of x is an integer 4, when I compute that to a fractional power, I get a floating point result, 2.0. Even though mathematically the square root of 4 is 2, Python makes a distinction when I use a fractional power. Here we're modifying z to refer to the m dot square root of x. Okay, now remember I did my import by saying import math as m. So I have to use m as the module that I want to get this square root function from. And this also gives me the same result. And as I have said, this is represented as a float value, even though mathematically it is an integer value. Okay, now here, if we can take this mathematical expression and represent it in Python using this sequence of operators, and notice that we've been careful. I just noticed that we have not been careful enough. There is an extra parenthesis in here that's missing. Okay, so we ought to be saying a gets x times, and then we're going to have a whole thing in parentheses here. 1 minus z cubed divided by minus 10 times y, all of that to the 0.5 power. Now, did I do my correct number of parentheses over here? So I've got 1 minus z cubed quantity divided by, okay, now of these various mathematical arithmetic operators, times, divide, minus, and so on, star has the highest precedence. So we are going to compute minus 10 times y first because of the parentheses, and then we're going to take that to the 0.5 power. So that will definitely work. When we divide 1 minus 7 cubed by that, we will get the correct result. If you are a little bit paranoid and want to make absolutely certain that you're dividing 1 minus 7 cubed over the square root of minus 10y, you can throw in an additional set of parentheses here if you believe that that clarifies what's going on. That set of parentheses is not required. Okay, and so here is my value of a. Okay, now, because we're taking a negative number and we're asking for the square root of that negative number, notice that the result I'm getting here is a complex number, not an ordinary float. So I've got my magnitude part, which is an ordinary float, but then I also have the, or I've got my real part, which is a float. I've also got my imaginary part, which is another float. And in Python, an imaginary value is represented by having a little j stuck on the end. J is, although in mathematics we tend to use I for the imaginary number, square root of minus 1, it's hard to read in code, and so often the letter little j is used instead to make that stand out. So if I ask for the type of a, yes, it is a complex number. Okay, now in my intro course, we didn't talk about complex numbers. You may or may not have seen complex numbers before. We're not really going to make use of them that much, but that's what's going on there. Here are some more examples. I'm saying x gets 4. So there's x. If I say x plus gets another integer, x remains an integer. It's now 6. And if I say x minus gets 1, okay, x is now the integer 5. Maybe I should be a little more careful to describe these assignment operators. Remember that if I say x times gets 3, this is equivalent to saying x gets x times 3. So that's how all of these assignment operators behave. And x now is going to be 15, the integer 15. Floor divide, the double slash, gives you the integer part of the division. The fraction part is truncated toward minus infinity. But in this case, in this example where I'm saying x divides gets, or floor divides gets 4, remember that this is the same, this is the same as saying x floor divide, x gets x floor divide by 4. X is positive, it's 15. 4 is also positive. The value of x divided by 4, if I used a single division, would be 3.75, right? So 12 over 4 is 3. 3 over 4 is 0.75. So what I'm going to get here is x gets the whole number. I'm running out of space. So I'm going to just say x gets the int part of 3.75. Okay? And so I'm going to discover that x is the integer 3. This is quite by contrast with if I had said, and I'm going to use a different variable name, x2 gets 15 over 4, x2 is now 3.75. The modulus operator gives me the remainder after division. So if I have an odd number, which I do, x is an odd number, and I say x mod gets 2, this is the same as x gets x mod 2, and 3 mod 2, that is, if we divide 3 by 2, the remainder is 1, and so that's going to give us x equal to 1. And then finally, x divide gets 3. Okay, ordinary division always results in a float, regardless of the types of the two operands. So here, x is the integer value 1, 3 is the integer value 3, but integer 1 divided by integer 3 is still a floating point value. All right, so that takes care of arithmetic operators. Next, we're going to take a look at strings. A stir variable is a sequence of 0 or more characters where the very first character in the string can be accessed using the index sub 0 when you use the square bracket operator. So here I'm saying s gets wombat, and now s sub 0 is going to be the one character subscript starting from the beginning of the string. So that is still a string. S is a string. S sub 0 is also a string. Whoop. S sub 0 is also a string. The length of S is 6, whereas the length of S sub 0 is just 1, right? But they're all strings. I can also access S sub 1 up through S sub 5. Okay, S sub 5 is the final one-character substring in a 6-character string. Remember that Python also allows me to count backwards. So if I say S sub minus 1, that's the character at the end of the string. And since this string has 6 characters in it, I can count my way down to minus 6, and that will be the first character in the string. Maybe we should remind ourselves what S contains. All right, so S is wombat. You're not allowed to go outside. So if I say S sub 6, forgetting the indexes for a 6-character string are from 0 to 5, I will get yelled at. Likewise, if I say S sub minus 7, I get yelled at. Okay. All right, so the stir data type has several operators that you can apply and several functions that you can apply. Here we have S itself. S is, a string is immutable. That is, it's not allowed to change. So if I tried to say something like, well, we've already seen that if I say S sub 0, I get the first one-character substring from the string. If I say S sub 0 gets a capital W, for the stir data type, this is not allowed. Does not support item assignment is a long-winded way of saying that that thing is an immutable data type. Okay. In addition to accessing individual items, I can also access slices using square brackets with the colon notation. Okay, so if I say S sub 3:6, now the second subscript in a slice is the subscript that is one past what you're actually trying to extract. We saw before that because Wombat has 6 characters in it, you can use individual subscripts from 0 up to 1, 2, 3, 4, 5. So 5 is the last individual subscript that you can use. But in a slice, it is fine to use a subscript that's one past the end of the entire string, because in a slice you get the characters from the initial character that you want, which in this case is sub 3, that's B, up to but not including the last character. So the slice of S from 3 up to 6 is bat. Okay? If I want to go all the way to the end of the string, I can just leave out that second subscript, and I'll the assumption is that I want to go all the way to the end. Likewise, I can access from let's say 0 up to but not including 2, or I can say :2 as an abbreviation. So if you leave out the first subscript, the assumption is that you meant 0. It turns out that you can use 2 colons. All right? And if you use 2 colons, the value after that second colon is a step size. So if I were to say S 0 colon 5, meaning from sub 0 up to but not including sub 5, so that's going to be Wamba. Whoop. All right, 0, 1, 2, 3, 4, up to but not including 5. So that's going to be Wamba. But if I say S sub 0 colon 5 colon 2, that means to give me every second character from Wamba. So that's going to be WMA. WMA is the acronym for something, but I don't remember what. Oh, in Minnesota, that's a wildlife management area. Okay. A couple of other things I can do with strings are to use in or find. I can test whether some string like BA is in S. That's true because Wombat does contain the substring BA. If I test whether W in caps is in S, that's false. I can I can say s.find O to get the index of the initial O, lowercase o character in Wombat. And we know that that should be 1. If the character doesn't exist, like if I search for X, I will get back the special value -1 to indicate that that value isn't in there. And there are several other functions that I can use with strings as well. Like I can say s.count a W, there's 1 W in Wombat, and so on. Here's some more s.upper. Okay, there's s.upper, s.lower. Well, let me say S2 is this is a test. So if I say S2.lower, I get that in all lowercase. Split is an extremely useful function to use with strings. Very often you will read in a line of text from some text, ordinary document file, or for some like a comma-separated value file or something along those lines. And you can split a line up into a list of line components by using the split function. So let me say that names gets John, Alice, Betty, Carl, Doug, Aaron. Okay, so here's names. And if I say M gets names dot split at the comma, this is how you would deal with the contents of a comma-separated value file, by reading in each line and splitting up each line into a list of the subparts, the substrings separated by the commas. Okay. Okay, replace is another useful function, and what's really useful about this is that unlike doing a direct modification on a string, okay, S contains wombat. Remember that I could not say S gets S sub 2 gets W. But I can say S gets a new string in which we replace W with capital W. S.replace does not directly modify S, but what it does is to return to me a modified version of S, and I can simply reassign that variable S to refer to that modified version. Okay, so that didn't technically directly change lowercase wombat to wombat with a capital W, but what it did was it scanned lowercase wombat, found the little w, replaced that with a capital W, not directly in the string, but instead in a copy of the string that is then returned, and I've modified S to refer to that new string. Okay. Within strings, well, first of all, remember that there are basically 4 ways of writing a string constant. We can either use single quotes, or we can use double quotes, or we can use triple single quote, yeah, yes, triple single quotes, or we can use triple double quotes. Oops, I forgot my... So I accidentally illustrated something I wasn't trying to, which is using the triple single quotes or the triple double quotes enables you to have a multi-line long string. Okay? So I can say long gets, this is a multi-line string containing 4 lines of text and a blank line. Okay, so I've got 1, 2, 3, 4 lines of text, and that final one has a new line character after it. All right, so \n is the new line character, \t is the tab character. If you want to represent a literal \/ character, you do that by doubling the backslashes. All right, so I can say S3 is, here is a literal \. All right, so so internally I've typed 2 backslashes, but if I display S3 using the print function, the double backslashes displays as a single backslash. I guess I should also show that if I say print long, rather than seeing these backslash n's in the string, what I get from print is, okay, the 4 lines of text with a blank line at the end. Now, there are many different ways of formatting results into fields of certain widths, or to specify the number of characters after the decimal point that you wish. Here is one of the oldest ways of approaching this. If I say print %5s, the %5s means that I want to display a string in a field that's 5 characters wide. Now, I typed a space, and so that's also going to give me a space. If I then say %-10d, that says I want to display a decimal that is a base 10 integer value in a field that's 10 characters wide. However, the minus sign here says that I want to have that left justified in the output field. And then I have another literal space, and now I'm saying %6.2f. F means float, and because a float has both a whole number part and a fraction part, I'm saying that give me 6 characters total width, but I want 2 characters after the decimal point. So of those 6 characters, the last 3 characters are going to be the decimal point followed by 2 digits. So the whole number part is going to occupy the initial 3 characters. By default, numbers are right justified. If we want left justified, as we did here for the integer, we have to include this minus sign. Okay, now I use another % sign followed by a tuple. I could use a list, but here I'm using a tuple of values that I want to have displayed according to these formats. So dog will be a string that will certainly fit into a 5-character wide field. 17 is an int that will certainly fit into a 10-character wide field. 3.1415926. Sorry. I'm a geek. What can I say? Now, I've typed many more than 2 characters after that decimal point for my, 8-digit representation of pi. But the format says to only display 2 decimal points. So what I'm going to get in my output is just 3.14. There we go. So I have 5 characters containing the string dog, and the string is right justified. Then I have 10 characters. Well, then I have a space. All right. Then I have this space. Then I have 10 characters containing the integer 17. So that's going to be 1, 7, and then 3, 4, 5, 6, 7, 8, 9, 10. So there's my So there's my 10 characters for the integer. Then I have a space, and then I have 2 spaces followed by 3.14. So I have 6 total spaces for my floating point value with 2 digits after the decimal point. Okay, so there are other versions of how to format scalar values, but this one is relatively straightforward. It's directly stolen from the C language printf format codes. Okay, so it comes from C. We can make decisions using if. We can read input using the function named input. Here, I think I had better get myself a file that I can edit. So let me open a file and put this stuff in the file. Okay, I need to shrink this file down. Come on. So that it will fit. Okay, so here I have an untitled file. I'm going to say save as, and I'm going to save this thing as ifelse.py. So I'm saying value gets input of enter your age. Okay, so the input function is going to display a prompt and wait for you to type a response. That response will be returned back to the code as a string. But we want an integer value for the age, so we're going to convert that age into an int value. Then we're going to ask, is the value greater than or equal to 75? All right, so there's my if statement. Notice that the if statement always has to end with a colon. It's easy to forget that. Print, and I'm too lazy to type all this stuff here. So I'll call this person a senior citizen, which is stupid. It's almost as much as what's on the slide. Okay. So, otherwise, suppose I want to test whether the person is greater than or equal to 16 but less than 75. And pretty much throughout the U.S., if you're 16 or older, you can get a driver's license. And then finally, I'm also allowed to have an else clause. Notice that the else also has to have a colon at the end of it. And we're just going to say too young. Okay, so in an if-else, you must have an if. You must compare at least one, you must check at least one value for whether that value is true or false. Here we're testing whether the variable whose name is value is greater than or equal to 75. If that condition is true, then we're going to do the indented statements contained within that if. And remember, and I'm sure you remember if you've written any Python code, that the indentation has to always be at the same level. Following the if, you're allowed to have any number of elif parts, including none. All right, here I've got one elif, but I could have multiple elifs. And optionally, at the very end, you're allowed to have at most one else part. Okay, so if I save this file now, which I can do in idle by pressing Control-S, and for that matter, that will work in just about any Windows editor application. Now I can run this program, and in idle I can say run module, or I can just press F5. And what did I do wrong? Invalid syntax. elif. Oh, it would help if I had my variable in here. So let's try it again. F5. There we go. Enter your age. 1234. Senior citizen. If I run the application again and say 50, I can get a license. If I run the application again and say 12, I get told I'm too young. All right, so that's a reminder of how the if, elif, else stuff works. And here we're just being a little more careful about the range checks. I'm not going to go through that particular example. All right, next we're going to take a look at lists. So a list is a sequence of values. To define a literal list, we use a pair of square brackets. We can have any types of values in a list. It's not necessary for all the values in the list to be of the same data type, although usually they are. So here I'm creating a vector containing 4 int values, 7, -1, 10, and 15. And I'm creating dog names, another array, another list containing, Barfy. It's not a very pleasant name. Whoops. Dog names. Gets Barfy, Fido. I forgot my quote mark over here. And Snoopy. Okay, now, as I can with a string, I can access individual items out of a list. So vector sub 0 is the value 7. Vector sub -1 is the last value, 15. Vector sub 6, that's out of bounds, so I'm going to get yelled at. Well, it's worse than out of bounds. There is no object named vecotter, but vector 6 is out of bounds. I can ask for slices. Dog names sub 1: is from Fido up to the end of the list, which is just going to be Fido and Snoopy. And here we're using the in operator to test whether something is in a list. We can use in for any data collection, such as a list, just like we'd use in for the str data type. Now, unlike a str, we can change the items in a list. So here's my vector. I can say vector sub 1 gets a 9. So a list is what's called mutable. In this case, I will actually replace the -1 with a 9 in my vector. The list data type, it turns out, has 11 named functions that you can apply, like append, insert, index, sort, reverse, and several others. So if I say vector dot append 20, that means to put the 20 at the end of the vector. You can also delete using the del command individual items out of the vector. So if I say del vector sub 0, that's going to shorten the vector to no longer contain what used to be its first item. Okay? You should know about comprehensions. A comprehension requires the use of a for loop, and you use that inside of the square brackets. So I'm going to create this list. I'll just use the example. A list containing I times itself for I in vector. Okay, so the for loop requires you to say the word for and then create some variable that you want to use to step through each of the items in an iterable. Here, vector is a list which is iterable, so we say for some variable in the items in this iterable, and what I'm going to do with each of those values is to square it. I'm going to say I times I. Those are going to become the initial values of a list. Okay. You can put any kind of thing that you like as items in a list. So a list is a list of int values. B list here is a list of tuples, all right? These parentheses here, the open parenthesis before the j and the closing parenthesis after vector sub j, creates a tuple of two items. So I'm saying B list gets a list of tuples where each tuple consists of the value of j and the value of vector sub j for j in range len of vector. Now, okay, so len of vector is the length of the list, which is 4. Range 4, you'll remember, I hope, gives you the values 0, 1, 2, 3. That is, values starting from 0 up to but not including the value of the argument to the range function. In this case, the value of the argument is 4. So I'm going to get tuples consisting of 0 and vector sub 0. That'll be my first tuple. Then 1 and vector sub 1, 2 and vector sub 2, 3 and vector sub 3. Okay, so I've got a list of tuples here. It's possible in a comprehension to use a condition so that values are inserted into the list only if some condition is true. All right, so here I've got this thing called word, which is forgot my gets A1, B2, C3. And I'm going to say CList gets each value C for C in word, but only if C is a digit. So A is not added to CList, but 1 is. B is not added, but 2 is. C is not added, but 3 is. So I end up with a list of 3 single-digit strings. Okay. Well, I've kind of already talked about loops in the context of talking about comprehensions here. I do want to mention, if you're using a loop through a list or a file or a range, and you want to alter what the print function displays at the end of each line, remember that by default, the print function displays a new line character at the end of each line. But you can simply say end gets a space character to display a space at the end of each line rather than a new line. For that matter, you can say end gets and an empty string if you want to just concatenate all of the lines together into a single long line. Okay. Not sure there's much interesting happening on this slide, so I think I'm going to punt on it. We're getting the squares of all the values from 1 up through 5. Let me just do this quickly. My list gets I squared for I in the range from 1 up to but not including 6. There's my comprehension. What did I forgot to give my variable name. Let me patch that up. For I in range. So here's my list. And now if I want to know how many items there are in my list, I can say, let's set a count equal to 0. And for v in my list, for each value in my list, just increase the count by 1. And then when we print the count, we see that there are 5 items in the list. On the other hand, if I wanted the total of all of those values, I could start my total variable at 0, and I can say for v in my list, total plus gets the value of v. So this time, instead of just counting the items, I'm doing what's called accumulating the items. And so total is the sum of these values. Okay, we can figure that out easily. 1 plus 9 is 10, 4 plus 16 is 20, 30 plus 25 is 55. So that looks right. To create an empty list, you can do a couple of different things. You can either say my list is just plain list as a function. Converting nothing into a list creates a list that is empty. You can also say my list gets and then just use empty square brackets. That also works. Here we are opening a file for reading. And we're splitting each line at commas, which is what you would do if you had a comma-separated value file. And then into my list, we are appending the value of x. So this is going to end up appending the list x, one list at a time, to my list. My list is going to end up being a list of lists. Okay, so if data.text contains these 3 lines, and we run this code, we're going to end up with a list of 3 lists. The first of those 3 lists is going to be dog, cat, then mouse, moose, and finally duck, goose. Another form of loop is while. And while requires a condition. While does not go through a specific finite collection of values. While will keep looping while some condition is true. In this case, we are going to ask the user to enter some kind of choice. And while the choice that the user typed isn't 1, okay, because according to our menu, 1 means quit. So while the choice isn't 1, then depending on whether the choice is 2 or 3 or something else, this loop will continue running until eventually the user gets around to typing a 1. The condition in a while loop can be, arbitrarily complex. So here we're testing whether the value of the variable found is false, all right? So not found is true if found is false. We're also testing whether the index that the user typed as input, well, actually here I guess we're just arbitrarily starting with an index of 0. We're testing whether that index is less than the length of my list. And we're going through and processing values. Now, this illustrates the idea that often in a while loop, you're going to need to initialize some variable to a value. In this case, we're initializing the index to 0. And then you had better remember to modify that variable in some appropriate way so that the loop is not an infinite loop. So part of our check in the while loop is we're testing whether index is less than len of my list. Well, if we say index gets 0, and we test whether index is less than len of my list, of course that's going to be true since my list is not empty. If I forget to say index plus gets 1, I've now got an infinite loop, and that's not a good feature. Okay, so that is part 1 of our review. We're also going to have a part 2 that I will post as soon as I am able to.